So today we're going to be actually this whole unit is talking about quadratic functions, but today we're going to be talking about vocabulary words and the parts of it. So what we're doing is we're using those trinomials x squared plus bx plus c, and we're graphing them, and we're learning how to graph them, and we're going to talk about the parts of them first. Now, x squared makes a parabola, and this is a parabola. Does everybody understand? This guy right here is a parabola. Now, our learning target for today says, I can identify parts of a quadratic. Underneath the word quadratic, I would like you to write parabola. If we have patience for like 4 seconds, I'm writing it down. So stop talking and write. Stop talking. Now, the equation or function that we're going to be graphing today and talking about today is f of x equals x squared. Now, what's another way that we can represent f of x? What was the other way? We've learned about it before. Man, you guys are on it. Does anybody remember what this is called?
X.
Yes, that's an x. I mean the whole thing over here. But what's it called?
Equation. Assertion.
Parabola.
Claim. Commentary.
I know it's
Function notation. And we can also write it as y equals x squared. Now, we are going to be talking about our vocab words today, what makes a parabola, and then you're going to get some homework. You have 3 problems.
Oh, yay.
And you're just identifying parts of it. Alright, are we ready?
Yeah.
So again, our learning target, I can identify parts of a quadratic. So you are going to be able to identify all these parts that I have arrows to by the end of the period. Does everybody understand?
Yes.
Now, down here, it says keywords to know. What does the word vertex make you think of?
Vertical line.
Vertices, the corners where they meet, right?
Yes.
Okay, but on a parabola, do we have corners?
We have like axis. They're on a road. It's not really corners.
Okay, so looking at this, what do you think the vertex would be of either of these?
The highest.
The middle, the highest, what else?
The lowest.
Fantastic. Both of you take a point. Sean, you get 2 because you answered twice. So the vertex,
Good job, Sean.
and I'm going to do this one in fuchsia, is the highest, or lowest.
Okay.
It's recording.
It's a nice example.
The highest or lowest point of a parabola.
So it would be the highest.
And a parabola is just the graph of a quadratic. Now, it's also the middle of a quadratic.
Got a question in the third row?
I know, but I'm still writing. Like, I know you have a question.
Oh, okay.
What's your question?
So, what is the highest point and the lowest point? Are there both vertexes? Is there 2?
There won't be of a parabola.
What?
There only be, I'm going to show you.
Oh, I see.
Okay.
I like your thought process of where you're going, but we're going to talk about why it can't be.
So there's not a separate name for the lowest point, they're both the same. They're both vertices.
Just watch.
Okay.
Parabola.
Wow.
Alright, so, did everybody have this written down?
Yeah.
Now, we are going to label our vertex of each of our graphs that we have. Now, we have 2 graphs, right? Do you see how it has arrows on the end? That means it goes on and on forever?
Yes.
So you can only have one vertex. You either have the highest point or the lowest point, because these go on forever. So over here, where's the vertex? Is this a vertex?
No.
What about this guy? What about this guy?
Yeah.
Is that the highest or the lowest? Okay. I will put you outside of this room and you will have to take notes in the hallway.
You gotta listen.
right, now this one, is this guy the vertex?
No.
This guy?
No.
This guy?
Yes.
Highest or lowest?
High. Why are you doing
Alright, now, the next part of what we're going to talk about, the next word is maximum. What do you think a maximum
The
is?
lowest number of something.
The most, right?
Yes.
But what would it be on a parabola?
The highest.
The highest, yes, take a point. So the maximum, and I'm going to do this one in green, is the highest point of a quadratic.
Are you?
I am, I'm dying.
Alright, so it's the highest point of a quadratic. Now, which of our two graphs, what was your question, John?
Okay, what's a parabola?
A parabola.
What's a parabola?
Okay, so a parabola,
This is a parabola.
Flesh
It
and
is.
fish. Piranha.
What's a quadratic?
that's what I've been saying over and over again.
Quadratic's not a maximum.
Listen to the whole lesson. I know it's a crazy concept for you. A parabola is the graph of a quadratic.
Right.
A quadratic is x squared. The graph of x squared is a parabola and looks like this. Do you want? This is a parabola, and that's the graph of the quadratic.
Parabola is the line.
The parabola is the graph.
It's not the line. What's the line? Quadratic.
Oh my god.
The quadratic is the function.
Right.
Okay? This is a quadratic. I know. Listen to me. Listen to me. This is a quadratic. This, I need a highlighter.
So the line is parabola.
Stop. This is a quadratic. This is a parabola. This
It's a
is a parabola.
Okay. So the graph is the
Flesh-eating fish.
function is quadratic. That's the parabola.
Yes.
I got it.
Alright, so is this vertex, is this a maximum?
No,
That's a minimum.
that's a minimum.
What about this one?
That's
Minimum.
That's us.
So underneath it, write maximum.
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 Like maximum highest.
Max says mom.
Alright, what is a minimum?
The lowest point of a quadratic.
Yes. Now, can we use quadratic and parabola interchangeably?
If you want to.
Yes, you can. Yes, take a point, Christian. Take a point, Carolina. Alright, so it's the lowest point of a parabola.
Why does maximum not say parabola also?
We literally just said that. Remember that talk we just had like 4 seconds ago about listening to the whole lesson? We can use them interchangeably
Not literally.
Why would you do that?
to torture you.
I understood. Point is understood.
Alright, so a minimum. Does the graph on the right or on the left have a minimum? Left. And is this the minimum?
No.
What about this? This is the minimum.
It's like Minnie from Mickey Mouse Club.
Look at you. Using your other notes. Take a point.
Thank you.
Good job. Squeezing her other way. You have another way.
Please finish the sentence.
Stop. Now, the axis of symmetry. What does the word symmetry mean?
Symmetric.
Symmetric.
Same.
So,
If I like slap my hands together, they're symmetric, right?
Yeah.
Because hopefully they match up.
yes.
All right. Now, what do you think it is on a yes? What do you think it is on a parabola? The middle, right? And do you think it's just like that middle point, or does it cut it in half? It cuts it in half. All right. So we have a specific way that we want to define it. It is a line that passes through the vertex. Alright, so it's a line that passes through the vertex, and it cuts the parabola in half.
Wait,
What's
what's your favorite tattoo? Oh, no, just put Z.
Alright, so looking at our graphs,
Caviar central?
what do you think is the axis of symmetry? Over here. This line, right?
Yeah.
This is our axis of symmetry.
Train in the water.
Appreciate you writing all my stuff.
Now, do you notice that this passes through the x-axis?
Yes.
The way you write the equation is it's x equals whatever that is. So what, we're going to say that this is at -2. Alright, so this passes through -2, okay? So you would write it as x equals -2. That's how you would write the equation of the axis of symmetry. X equals whatever the x value of your vertex is.
But how do we get X?
Can you scroll down? Can you go down a little bit?
Say it to me again.
How do we get X equals -2?
Because I said that this passed through the x value of -2. So you draw it through the vertex and you hit the x-axis. So wherever it hits the x-axis, that is your equation. So you see how we drew this line and it hit right here at -2? This is where it hit there. So that's my axis of symmetry, x equals -2. So that's the point where it cuts my graph in half.
So we're going to be graphing it on a coordinate plane.
Yes.
Oh, okay, that makes sense.
Yeah. Alright, over here, where is my axis of symmetry here?
At the bottom.
Right through the Y.
Right through the y-axis, right?
Yeah.
Awesome. Take a point, both of you. So what would the equation be for that? X equals what?
0.
0, yeah. Take a point. So that's our axis of symmetry through the axis. It's through the y-axis right here. And it's x equals 0.
Where is it?
It's through the y-axis. You see how that cuts it in half right there?
If the deal's the point. Oh yeah, I like that one. I like the blue useless.
Okay, now the next word is roots or zeros. So what do you think that is?
Well,
Roots are like the square roots, right?
When it goes to the
Yeah,
Y.
that is actually.
It's like what trees do.
It's a part of the parabola. But what part is it? What have we not?
The two. Like,
The points where it crosses the X.
Which axis? The x-axis, yes. Take a point, Hufflepuff and Sean. Alright, so it's where the parabola crosses the x-axis. Now, why do you think they're called zeros? Carolina?
I'm guessing.
Kind of. Yes, but I want to know. Okay. Yes.
Does it have an angle?
No.
Dude, it's a piece of paper.
It's because it's a quadrant.
A triangle is also on a piece of paper and it has an angle.
I thought he said ankle. I was like, well, why would it have an ankle? It's a piece of paper. My bad. Just make sure. Sorry, Chris.
Stop talking.
Okay.
Alright, so let's look at which one is our root. Okay, so over here, is this guy the root?
no.
It says where the parabola crosses the x-axis. Is that where it crosses the x-axis?
Yeah.
So this is a root. How many roots does it appear we have?
Two.
And you're going to have 2 every time. Well,
Hey, sure.
no. You can have 2, 1, or 0. And we're going to talk about that more tomorrow.
Scroll down a little bit.
Where am I scrolling to?
I know to the right.
You're going to have to wait a minute. Alright, now over here. These are also called root. These are the roots, but we're going to call them zeros over here. Now, why do you think they are zeros? Look at where it's at on the graph. It's on the line, right? And it's on the x-axis. So what does that mean our y value is?
0.
Our y value is 0. Take a point. So that's why it's called 0. It's where y equals 0. So let's write that right here. Y equals 0. And our last word is the y-intercept. What is a y-intercept? Look at you go. Take a point.
I was trying. I didn't realize it was that loud.
So it's where the graph crosses the y-axis. Okay, so do we have a y-intercept of this graph?
No.
Oh.
Yes.
Yes.
Right here? It crosses the y-axis right there, right? So that's the y-intercept.
Oh. Okay.
Now, what about over here?
No.
No. Wait. Yes.
Right here, right?
Yeah.
So not only is this a vertex, not only is it a minimum, it is also the y-intercept.
That dot is so special.
I know.
So it can be both.
It can be both. Alright, so before we go to the next page, I want to show you something on Desmos.
It's that graphic app.
Alright, so what I want to show you is f at x
Wow.
equals x squared. Okay, so x squared, it opens up, right? It makes a u. One more time and you're out. Alright, so it opens up. Now, what do you think I could do to make it become a mountain? No, wait. Does this have a maximum or minimum?
Minimum.
What's the vertex?
0.
What's the y-intercept?
It's right there.
What is it? No, where does it cross that y-axis?
At the origin.
At the origin is 0.
Yeah.
Where does it cross the x-axis?
At the origin.
At the origin. So the root here is 0, the y-intercept is 0, the vertex is 0, it's a minimum. How could I flip this over and make it a mountain instead of a u?
Negative.
Where?
X
Negative x squared.
Like that?
Yeah.
Okay. So is that a maximum or minimum?
Maximum.
Alright. How could I make this graph skinny?
Wait, what? Take out the square? Like this x? Well, we'll put one. I did something indeed.
Okay, so we need that. How can I make my parabola skinny?
Do you add something on the edge?
Tell me what I could add. Okay. So Carolina wants to put a 2 right here. Did that make it skinny?
Yeah.
Awesome. Good job. Take a point. How can we make it fat?
Negative.
Negative?
Negative
Make it
number.
McDonald's.
All right. -3. What did that do?
Positive 3.
That flipped it over and made it skinny, right?
So maybe
Okay.
you could do negative 1x or negative 2x.
Did you do a number after the X?
Where?
After X squared?
Right here?
Yeah.
So what would you want me to put?
6.
X10.
Yes. Yeah.
No, that can't work.
What about 3?
So out front?
X and
3.
this. Wait.
QB.
Oh wait, taking out the eggs
and putting in a number.
That's what you guys want me to do?
No.
Well, you're the teacher. You tell us what to do.
No, I want you to tell me how to make it.
X and put a number X.
Okay?
No, where the F.
No.
F
Boy. Oh my
Not
God.
happening.
Nope, can't change the F at X. That's why. Can't change it. Alright, so remember, we put a 3 out here and it made it skinny, right? You could do parentheses, but what would I put in the parentheses?
You'll multiply it by another.
Thank you, baby. That's what we figured out, but what number?
A nice kid.
Okay? So a -2 flips it over, made it skinnier.
Yeah.
We need it to be wider.
No, 4. 4.
Okay, so 4 made it super skinny. Okay, so let's do this. This is what I'm going to do. That's my original function. And I'm going to say that this is my new one. Equals, and we're going to do 4x squared. Alright, so remember, this is my original. The red is my original, x squared. And that's the one. We want it to be wider. We want it to be wider. So if I put a 4, it made it skinnier. We did negatives and it flipped it over. So -2 flipped it over.
So, could you do parentheses?
Mm-mm.
No.
Wait, would you put like the x 2 on the outside of parentheses?
Mm-mm. Alright, so 5 made it even skinnier. What if I put a 7?
Even skinnier.
What if I put an 8?
No.
What if I put a 9? So as our number gets bigger, it gets skinnier.
Put 0.
So maybe we should put numbers.
What about 1?
So if I make my number smaller, if I put a 1, that's the same thing. If I put a 2, it's still skinnier. We need it to be wider than the red. So what can I do?
-0.
I'm gonna have a heart attack.
Could I what? Cube it?
Yeah.
Okay, so cube it looks like this. Quadruple it looks like that. That doesn't, it's a funky. So we need squared, and we need a number out there that's going to make it wider. So as the numbers got bigger, it got skinnier. What do our numbers need to do?
Get smaller.
So how can we make our numbers smaller?
Negative.
0.5. Take a point. So if I put 1 divided by 2, look at that. Did that make it wider? All right, how could I make it wider again? What could I do?
0.25. Maybe.
Yeah.
Yeah. Okay.
0.5.
0.0001.
Just anything point. Just works.
So a fraction makes it bigger, right?
Yes.
And a whole number makes it,
Smaller.
okay. Now, what if I wanted to move it to the right?
You put something in place of the x.
The x squared stays there every time. What if I wanted to move it to the right? What could I do? We don't put anything out front this time. I want to move it to the right. Move this to the right. Say I wanted to move it. I literally want to pick this up and move it to the right 2 places. What could I do?
Change the action parentheses.
Nope.
So you can't pick a 4 and move that over.
No.
Change that.
No, guys, we don't change this. We don't change x squared. Tell me what I could do. Add what? Okay, so that moved it up, right?
Yeah.
But if I add 2 to the x squared on the outside, it moves it up. How could I move it down?
Subtract.
Subtract 2?
All right, so we see how it moved it up and down.
Yeah.
How could we move it left or right?
Multiply. Alright.
Oh, I'm so sorry that I'm making you think and your little brain doesn't want to work.
This is in the real world. I'm just wondering.
With parabolas?
Yeah.
If you're trying to figure out the range of a rocket and see how far it goes up in the trajectory and see how long it's going to hang, especially with fireworks, and see how high it's going to be so that you don't hit oncoming aircraft or anything like that, like there's so many ways to use this.
I'm gonna fish, so how am I gonna use this?
The arc of your line. As you cast it, you know it goes up. So you need to figure out how far it's going to go. If you just do this, it's not going to go as far, is it? You have to flick it at a certain point for it to go up.
No, it's got nothing.
I'm gonna fish. I don't
Wait,
know.
would you
That's
add it?
literally what I just
Would
said.
you
Well, I
add it
mean,
in the
you
correction?
you've got something special. You don't need to be fishing.
Would you add it with the
A
correction?
weightlifter, powerlifter. Possibly a little. I'm gonna fish. I don't know.
What did I do?
You moved it.
I moved it to the right by what?
-2.
And I put a parentheses and I put it on the inside. What if I wanted to move it to the left?
You do +2. Oh, okay, I'm retarded.
No, you're right.
You're right. It's the opposite. All right. What if I wanted to move it left 2 and up 2?
You do +2
Do you
-2.
subtract? Put a number.
Did I move it left 2 up 2?
Yeah.
All right. What if I wanted to move it left 2 down 2?
-2.
Subtract.
What?
What if I wanted to move it right 2 down 2?
X -2 and then X +2.
I need a whole bunch of practice with this.
So, yeah, we're going to keep practicing. This is called vertex form. And this helps you find the vertex. So our vertex is at 2, -2. You take the opposite of what's in here and that number, and that's your vertex. That's it. So our next sheet on here, we're going to use this some today, but more at another time. It talks about the y-intercept, and this is if you had a rocket and you shot it up in the air. Okay, so our rocket starts over here,
Or.
all right, and it travels up. So this is how high off the ground did the object start once we get to this point.
Like a rock.
Yes.
Like a rocket.
All right, our vertex is when is the object at the maximum height? So when is it? That's the time. And how high did it get? And then how high is it after a certain number of seconds? We're going to do all of this either using a rocket or using Angry Birds. I can't decide yet which one I want to do.
When your neighbor
Or
turned the
when you
TV
nuke
down, so
Syria.
you catapult him to North Korea.
Or you nuke Syria.
Jesus Christ.
You know, that TV's too loud. This thing doesn't want to. That would be fucking good.